Let's try a few evaluation questions from Chapter 4, describing the relationship between two variables. The scatter diagram below shows, we want to determine what it shows. First, we want to decide whether it's a linear or non-linear relationship. There does appear to be a cluster of data points to make it look linear. We want to decide whether it's positive or negative. They do seem to be oriented in a positive fashion that's rising from left to right. Whether the orientation is moderate, strong, or weak. I would say that this is a moderate relationship between the data points here. So we have a moderate positive linear relationship. Let's look at another diagram. Here we want to decide whether it is linear or non-linear. Here it appears to be linear somewhat, not as good as the one we had before. You definitely don't see a curvature pattern, so we would say linear. It is going down from left to right, so it's a negative relationship, and it's not very clustered together. So I would say that this set of data appears to have a weak negative linear relationship. Weak negative linear relationship. These are the types of words you're going to use when you describe a set of data. The least squares line below could be, if we look at the red line, it has a positive slope. So if you look at your choices here, that eliminates B and D. If you look at your y-intercept, it should cross the y-axis at 1, or with the other choice, it's going to cross the y-axis at -3. This line appears to cross the y-axis at 1 if we were to extend it. So I would say that our least squares regression line is A, y equals 1.5x plus 1. In a study of y equals weight in pounds versus x equals age in months of certain cats, the least square regression line was found to be y equals 0.7x plus 0.9. The slope has the interpretation. Slope is interpreted as y over x, and our slope is 0.7. So every change in weight in pounds versus the age in months. So we would say cats, on average, because slope is the average rate of change, gain, because it's positive, 0.7 pounds per month. Our denominator here would be a 1, so that's 1 month. A coefficient of determination, r squared, measures, the coefficient of determination is always going to measure the percentage of the total variation explained by the least squares regression line. What percentage of the variation we can contribute in the y variable to the x variable and vice versa. So we've got the percentage of total variation explained by the least squares regression line. If the unexplained variation is much larger than the explained variation, then, so we have r squared is smaller than the leftover, then the percentage of the variation explained by the least squares regression line could not be very high. Okay, so if the explained variation is our r squared, or coefficient of determination, then the unexplained would have to be large. So our percentage of total variation explained by the least squares regression line is not very high, which means there's not a